Hi there, Mr. Sutton bringing you the AB Calculus Chapter 5 Quiz 4 review answers on average value and integrals by substitution. On this problem, we're trying to find the average value of this function over the interval from 0 to 2. Now in general, average value, we find that with the formula 1 over b minus a times the integral from a to b of f of x dx. So in this case, we have 1 over 2 minus 0 times the integral from 0 to 2 of the f function, which is this function up here, negative x cubed minus 3x squared. So let's go ahead and take the antiderivative of this. We have a 1/2 out in front from our fraction there. And then inside, this bumps up to a 4, so I've got negative 1/4 x to the 4th. Minus, this bumps up to a 3. Dividing by that, we have x cubed. Again, evaluated from 0 to 2. So I've got 1/2 times all of this with 2 plugged in, minus all of this stuff with 0 plugged in, inside a big parentheses next to this 1/2. Okay, so all the stuff in this second bracket is gone because I'm multiplying by 0 all the way through. Over here, I've got, let's see, negative 1/4 times 16, which is negative 4. And then this is negative 8. Negative 4 minus 8 is negative 12. Half of that is going to be negative 6. Now, on a free response, please note that you didn't have to go any further than this part right here where you had all the constants written out, but if you do choose to simplify, there it is. For this problem, we want the average value of this transcendental function from 1 to 5. So I'm going to have 1 over b minus a, which is 5 minus 1, times the integral from 1 to 5 of 3e to the x minus sine of x dx. And taking my antiderivative, well, I've got a 1/4 here, but now taking my antiderivative, I've got 3e to the x, and then antiderivative of negative sine of x is positive cosine of x. Evaluating that from 1 to 5 now, we have 1/4 times all of this stuff with 5 plugged in, minus all of this stuff with 1 plugged in. And I'm not going to go any further here because first off, I've got all constants, so if this is a free response problem, I'm pretty much done if I have all constants. Also, we really can't do much more with cosine of 5 and cosine of 1. Those don't have nice, neat, non-decimal values. So we're just going to call it a day on this one. For this problem, I'm trying to find the indefinite integral of this expression in terms of x. So since I have an inner function and its derivative is elsewhere in the problem, I'm going to try to use u substitution on this. I'm going to start by letting my u value equal 6x to the 4th plus 1. So taking my derivative then, du equals 24x cubed dx. And then I'm going to isolate dx by dividing both sides by 24x cubed. And now I don't have to worry about u values in terms of the limits of integration because this is an indefinite integral. So I can just go straight to replacing stuff with u's. So we've got negative 24x cubed times the sine of u times du over 24x cubed. These 24x cubes cancel nicely, so this is just negative sine of u du. Antiderivative of negative sine is positive cosine of u plus c. And then replacing u with the 6x to the 4th plus 1, because they said they want this in terms of x, I end up with the following. And it's done. For this problem, I want the indefinite integral in terms of x for this function. So this expression down here, this 2x to the 6 plus 8, since that's in the denominator, that kind of counts as an inner function. It's in the function x to the negative 1, you could think of it as. So I'm going to let the stuff in here equal my u. And I'm using u substitution because I have this inner function, and I also have the derivative of this thing elsewhere in the problem. So I have u equals 2x to the 6 plus 8. So then du equals 12x to the 5th dx. Dividing both sides by 12x to the 5th, I have du over that I can now substitute in for dx. And then going back here, I've got 18x to the 5th over u times du over 12x to the 5th. These x to the 5ths cancel. I have 3 halves if I reduce the 18 over the 12, and I'm going to call this u to the negative 1. You could call it 1 over u, it doesn't really matter. The antiderivative of u to the negative 1 or 1 over u, that's going to be ln of absolute value of u with this 3 halves out in front. plus c, don't forget your constant of integration, and I also have to replace the u value with this 2x to the 6 plus 8 to get my final answer. For this problem, we're trying to find this definite integral. Since I can't easily simplify this, if at all, and I noticed that if I took the derivative of part of this with the x squared, I might get something with the x here. This seems like a good candidate for u substitution. So I'm going to let my u value be this 2x squared plus 1 expression inside the radical. And now if I take the derivative of that, I'll have du equals 4x dx. And then dividing both sides by 4x, we have du over 4x as equivalent to dx. Now we also are going to need to swap out the 2 and the radical 12, which begin as x values. We need to turn those into u values. So if I start with an x value of 2, using this u equals 2x squared plus 1 conversion up here, we've got 2 squared is 4 times 2 is 8 plus 1 gives us 9 for that u value. And if we have the x value radical 12, well, radical 12 squared is 12 times 2 is 24 plus 1 is 25. So I've got the integral from 9 to 25 now, and I'll have 2x times the square root of u, and instead of dx, I'll replace that with du over 4x. Simplifying this a little bit, the 2x and the 4x can reduce to just 1/2, and I'll turn this u into u to the 1/2 just so I can easily do my reverse power rule on that. So if I apply my reverse power rule, this exponent bumps up to 3/2, and I'm multiplying by the reciprocal of my exponent, which is 2/3. So 2/3 times 1/2 is going to be, the 2's cancel, so you have 1/3, and then u to the 3/2. And that's all going to be going from 9 to 25. So when I rewrite this, I'm going to use radical form. This is really the square root of u to the 3rd power. So I have 1/3 times the square root of 25 cubed minus the square root of 9 cubed. So that's 1/3 times, well, let's see here, square root of 25 is 5, cube that we have 125, and square root of 9 is 3, cube that we have 27, so minus 27. This is going to be 98 in here, so 1/3 times 98 is just 98/3. And I can't really simplify that any further because 98 is not divisible in any way by 3, so that's as good as it gets. But of course, you didn't actually have to simplify it when you had all the numbers written out at this second to last step here. On this problem, I'm trying to find the definite integral of sine over cosine squared of x from 0 to pi over 3. Now, you might recognize this kind of problem. It actually is possible to do this without substitution. If you wrote this as 1 over cosine times sine over cosine, that's really secant of x times tan of x, which has a pretty straightforward antiderivative. But if you didn't spot that, you could always use substitution on this. So cosine is my inner function here, and sine is its derivative, or close enough to its derivative that we can use substitution. So I'm going to let my u value be cosine of x. Du is going to be negative sine of x dx. And then dividing both sides by negative sine, we have du over negative sine of x dx, or negative sine of x equals dx. There we go. I also have to replace these x values up here with u values for my limits of integration. So if x is 0, u is going to be the cosine of 0, which is 1. If x is pi over 3, u is going to be the cosine of pi over 3, which is 1/2. So then I've got the integral from 1 to 1/2, which seems kind of backwards, of sine over u squared times du over negative sine of x. Sines are going to cancel. This is going to be negative u to the negative 2 du. And then using my reverse power rule, this bumps up to a negative 1. Dividing by negative 1, I have positive u to the negative 1, evaluated from 1 to 1/2. And then plugging in both of these and subtracting, I've got 1/2 to the negative 1 minus 1 to the negative 1. Well, 1/2 to the negative 1, that's just the reciprocal, which is 2. The reciprocal of 1 is 1, so this is really just 2 minus 1, which comes out to 1.